Did you know that you could take a Raspberry Pi and make it into a wireless access point? In this episode of Graybeard Wi-Fi, I'm going to show you how. Hi, this is Chris, and welcome to Graybeard Wi-Fi, your experienced source for information on anything Wi-Fi. And as I mentioned in the introduction, I'm going to take a Raspberry Pi and I'm going to make it into a Wi-Fi router. You can also make it into a Wi-Fi access point as well too. So I'm going to talk about why do we want to do this, and then I'm going to talk about some limitations when it does come down to using this platform in order to be a Wi-Fi router or an access point. Then we're going to jump into a step-by-step configuration to get one up and running and run some tests in that to prove that it does work. So why do we want to use a Raspberry Pi as an access point or a Wi-Fi router? There's a couple of reasons why we want to do this. So one is a cost-effective solution. So utilizing a Raspberry Pi might be cheaper than many enterprise or commercial Wi-Fi routers or access points. It does have a lot of flexibility when it comes down to modifying settings or even putting specific applications to fit specific requirements. It does have low power consumption compared to traditional Wi-Fi routers or even access points, and they can be used with battery packs. So with that in mind, we can also have these as portable and very compact. So we can have them for a smart home application, Internet of Things. They could be embedded into a robot in order to have communication from, say, a laptop into the actual robot itself, or other type of remote applications. Now, here's an example of what I'm going to be personally using this particular Raspberry Pi for, as I am an amateur radio operator and I want to do what is called digital modes. And digital modes requires a computer to interface with an actual radio. And so instead of turning around and bringing my laptop out into the field, because I do what is called parks in the air, which I go out and into the elements and do all this stuff, instead of bringing my laptop that could be subjected to weather conditions and stuff like that, plus also lugging around size and weight and stuff like that, I can just bring a Raspberry Pi, connect it up to my radio, and it will be able to do that interface so that it could do digital modes. Now, instead of bringing a keyboard and a monitor, I want to have the ability to access those applications on here. So the way that I want to do it is have a wireless access point on it, activated and running. So then I can use a tablet, I can use my phone, or I can, yes, I can even bring out a laptop, I can connect up wirelessly, and I can operate those applications. Now, there are limitations to using a Raspberry Pi as a wireless router or a wireless access point. So the first one is going to be limited to network speed and frequency support. So Raspberry Pi 3, the Raspberry Pi 0 and below only support 2.4 gigahertz. So there is going to be some speed limitations when it does come down to that. Raspberry Pis 4 and later do support 2.4 and 5 gigahertz, but they will still underperform commercially available Wi-Fi access points or Wi-Fi routers. Okay, so I left a link in here on the raspberrypi.com website to go and show you what are the various limitations in that with regards to the different models of Raspberry Pi. The next thing, it has no dedicated hardware acceleration. So Raspberry Pis themselves are software dependent, and because of that, it could cause some performance issues. Now, the big thing when it comes down to some of these performance issues is that we're also going to be limited to the number of clients that we can have. So Raspberry Pis themselves can handle 5, maybe 10. 10 is really pushing it, clients before it could start degrading. Now, in my application, there might be only 1, maybe 2 clients are going to connect up to this at a time. So it's not going to be a problem. But if we go beyond 10 clients, they're going to be connecting up to these, we might start seeing some instability and some performance issues when it comes down to the actual Raspberry Pi itself. And I'm going to talk a little bit about that in a couple of minutes. And so the next thing we also need to talk about is the antennas on these Raspberry Pis. So when I talk about the internal radio for the Raspberry Pi, I'm not talking about something that you would plug into an external USB, okay? I'm talking about the built-in. So that's all I wanted. I wanted a limited amount of parts to be added on. So using the internal Wi-Fi adapter, the chipset, it has an internal antenna. It's not really necessarily been built for being an access point. It's been more designed to be a client. And so the internal antenna itself will lack in range and some power capabilities. Now, for my application, I'm most likely going to be within a couple of feet of this Raspberry Pi. So it's not going to be a big deal. But if you're interested in building one of these, say, for example, at home, and you are going to put it on the main floor of your house and you want to have coverage going into the basement or on the second floor, this might not be the solution. Okay. Maybe in a later video, what I will do is I will build one of these with an external USB adapter. That would help out with regards to coverage if you want to go ahead and do this. But I just wanted to keep today's video as a part of just it being self-contained. The next thing that we got to be concerned with is CPU and RAM constraints. So running lots of applications on these Raspberry Pis, along with being an access point, will overburden the CPU. So the applications that I'm going to be running on this Raspberry Pi for my ham radio, it's not going to be a problem. They're pretty lightweight applications. And so then that means I can add on the capabilities of having an access point on here as well. But if you are going to run higher level applications on there, or how many clients associated with this, then it will start degrading and it just won't be a pleasant experience. The next part is security. So if we want to put a firewall on, so say for example, you're going to use one of these and plug it into Ethernet and use one of these as a Wi-Fi router, you want to put some sort of firewall on there. So configuring a firewall on there can be easily done. But the problem is that it's going to add more resources. So not only does this poor Raspberry Pi have to deal with the Wi-Fi component of it, but it also has to deal with such things as firewalls. So it will take up more resources on it. At the time of this video, Raspberry Pis won't support WPA3. Using WPA2 personal with strong passphrases and that should be fine. So the application I have, that's what I'm going to do. It should work fine. But if you do have any other higher level security where you might need WPA2 Enterprise or even going WPA3, you might want to not use this for that type of application. Now, we also, as a good security practices and procedures, also want to make sure that all of our applications and firmware are up to date. And so it might require you to have to every so often log in, connect this up to an internet connection and do an update. Now, if you have this connected all the time, you can set up a cron job and that to check every so often in order to do these updates so to ensure that there's no bugs or anything like that into the Raspberry Pi. Let's get started on configuring the Raspberry Pi. So I am going to shift screens and show you step by step on how to accomplish our goals of making this into a Wi-Fi router or an access point. Okay, we're into the Raspberry Pi that we're going to convert into a Wi-Fi router. And the first thing that we're going to do is we're going to open up a terminal window and we need to set the wireless local area network localization. This is important so that it actually enables the wireless LAN adapter on the actual Raspberry Pi itself. So the way that I go ahead and do this is I go into rasp p config. Okay. And then what I will do is I'll go down to localization options and I'll come down to L4 WLAN country, set legal wireless channels for your country. And so I'm in Canada, so I'm going to go ahead and I'm going to select Canada. I'm going to hit enter and the wireless country is set to Canada. So we're good with regards to that. Just tab over and click on finish. Okay, the next thing that you want to do is an app update and app upgrade -y. Okay, I've already gone ahead and done this already, so I'm not going to bore everybody with sitting there watching how all this progresses. So you want to make sure that we do have all of our packages up to date in order to do the install. Now, one of the things that I've noticed in the latest and greatest versions of the Raspberry Pi OS is that they don't use DHCP CD. And I like using that. So what I'm going to do is I'm going to go ahead and install it. So I'm just going to go app install DHCP CD 5. And I'm going to say yes. I'm going to hit enter. And I'm going to stop the video and I'll come back in that when this is all complete. Okay, so we've completed installing DHCP CD. And so what we're going to do now is I'm going to go and I'm going to clear this out first. And I'm going to go and do a system CTL enable DHCP CD. I'm going to hit enter. And then the next thing I'm going to do is system CTL enable start DHCP CD. Hit enter. It's going to start that. Now what I'm going to do is I'm going to disable the network manager. That was the default method that the Raspberry Pi would actually go and manage all the network connections. So I'm just going to go system CTL disable network manager. I'm going to hit enter. And then I'm going to enter in the command system CTL stop network manager. Okay, so we get that part done. Now what we're going to do is I'm going to give the wireless interface a static IP address. And so I'm going to just clear this out. And what I'm going to do now is I'm going to do nano etc dhcpcd.conf. And so now what I'm going to do is I'm going to go all the way down to the bottom. I'll do a space in there. And I'm going to type in interface WLAN 0. I'm going to hit enter. And then I'm going to give it its static IP address. So static IP address equals, and I'm going to do 10.0.17.1 with a subnet mask of /24. And then I'm going to just tell it its default gateway or the router itself, which is going to be the actual Raspberry Pi itself. So I'm just going to say static routers equals 10.0.17.1. And now I'm also going to put in some DNS servers. So if we do happen to connect this up to a wired connection and want to use it as a Wi-Fi router, it's going to be able to go off and send a DNS request and that to some DNS servers. So I'm just going to do static domain name servers is equal to 8.8.8.8. And then I'm just going to do 1.1.1.1. Now you could put in your own DNS servers if you do have them. If you are on a network that does have another router or anything like that that does the DNS, you can point it at that. But I'm just doing this for the purposes of actual demonstration. So just set it to these particular DNS servers. And so now what I'm going to do is I'm going to do a Control X, and I am going to save the modified buffer. And I'm going to hit enter. Okay, and so now what has to happen is we have to do a reboot. So I'm going to reboot it and then I'll come right back. Okay, so we just finished rebooting after installing DHCP CD, and we also gave WLAN 0 a static IP address. Now, it's not ready yet, so there's a couple of more things that we've got to do in order to get this to work. The next thing we're going to do is we're going to install a couple of applications that is going to turn the Raspberry Pi's Wi-Fi interface to have the ability to do access point mode, essentially. Also as well to a DHCP server, and also as well we're going to put in IP tables and that so that we can do network address translation. The first thing that we need to do with that is just utilize the command apt install hostapd DNS mask, and that's with a Q, not a K, IP tables persistent. And then we're just going to hit and then a -Y afterwards to say yes afterwards. So I'm going to pause the video and I will get right back when everything is done. Okay, so we have it done. There was a little step in there that it will pop up and it'll say with regards to IPv4 and IPv6, just use the defaults, hit yes and yes. Okay. So now we've got that installed. What we have to do is, first of all, I'm just going to clear this off and I'm going to increase it one more. Okay. So what we're going to do now is we need to deal with host APDs. So we have to unmask it, then enable it. So to do that is system control unmask host APD. And then we just go system control or system CTL, enable host APD. Okay, so we got that part taken care of. Now what we're going to do is we're actually going to go in and do some configuration. And so we have to create a host apd.config file in the /etc/hostapd directory. So we're going to go nano etc host apd and then host apd.conf. And I'm going to hit enter. Now, we have to put some information in here and it has to be exactly like this or else things are just not going to work. So this particular file here is where we tell host APD some of the information we need for it to do Wi-Fi. So the first thing we're going to tell it is which interface. So interface, and I just have one on here, WLAN 0. And then I'm going to tell it its driver, and it's going to be equal to NL802.11. And then I'm going to give it its SSID, so the network name that we're going to use. So in this case here, I'm just going to call it Graybeard Ham because it's going to be for my ham radio project that I'm going to be working on. You can call it whatever you want, and I'm going to be doing a video later on with regards to SSIDs. Now, we have to set the hardware mode. And so what the hardware mode is it basically tells which radio are we going to use. Are we going to use a 2.4 or we're going to use a 5 gigahertz radio? And so what I want to use this on here, I want to use the 5 gigahertz. So I'm just going to use HW_mode equals to A. So this is going to be based on 802.11a, which is 5 gigahertz. And then after that, we have to tell it which channel to use. Now, I'm just going to keep it simple. I'm just going to say I'm going to use channel 36. And then WMM enabled is equal to 1. And then we're going to go MAC address or MAC ADDR underscore ACL is equal to 0. Auth algs equals to 1. And then ignore broadcast underscore SSID equals 0. Okay, then we're going to do WPA is equal to 2, so we're going to use WPA2, and then the WPA passphrase. And I'm just going to, for the purposes of this demonstration, I'm just going to use test 1, 2, 3, 4. You should use a lot stronger passphrases. The Wi-Fi Alliance recommends 20 characters. Scramble those characters up between uppercase, lowercase, numbers, special characters. Okay, so just for the purposes of today, I'm just going to go and just keep it as test 1, 2, 3, 4. WPA key management, MGMT, is equal to WPA pre-shared key, and that's what we're going to be using. And then RSN is going to pairwise. It's going to be equal to CCMP. Okay, so we're done with that, and so what we're going to do is just do a Control X, hit Y, and then you're back out into the desktop screen. Okay, I'm just going to clear this up. So then now what we have to do is we have to tell the host APD daemon where that particular file is, where all the settings are. So what we're going to do is we're going to do sudo etc default and host APD. Oops, forgot the nano. Okay, and so we're going to come down to this line here. Okay, I'm just going to highlight it here. Okay, we need to come down to this line here. We're going to uncomment, so just basically erase the hashtag or the pound symbol. And inside here, we're going to put the location of our hostapd.conf file. And so that would be etc hostapd.conf. Okay, Control X. We're going to hit Y to save it and hit enter. Okay, so we got that part done. So now what we're going to do is we're now going to set up the DHCP server in there. So that means whenever client, like say my tablet, when I'm out in the field with doing ham radio, will authenticate, associate, and go through the four-way handshake, then it's going to, once it's all done that and it's associated, it's going to be getting an IP address from the actual Raspberry Pi itself. So what we need to do is we need to go and configure that. So what we're going to type in is, I'm going to clear this off first. I'm going to say nano etc DNS mask with a q.conf. Okay. And so what I'm going to do now is I'm going to page down all the way down to the bottom. I'm going to have a space there. And there's going to be a few things that we're going to input at this particular point. So we're going to go interface is equal to WLAN 0. So we're telling it that it's going to listen for DHCP requests and send out DHCP addresses, IP addresses through that interface. So then we are now going to specify a DHCP range. So we're going to go DHCP range, dash range, is equal to, and I'm going to say 10.0.17. We're going to say 20, and then we're going to put a comma, and it's say 10.0.17.30. Okay, I'm not going to have too many devices connecting up to this, so I'm going to keep the DHCP ranges really, really low. And then we're going to turn around and say how long does this DHCP address the least time is. And so I'm going to turn around and just say 24 hours. Got to keep it simple. Okay. Then we're going to say DHCP option, and it's going to equal, we're going to say 3, and then we're going to put a comma in 10.0.17.1. And so this is our gateway address. Okay. So this would be, because this is a Wi-Fi router, it's going to be the address of the Wi-Fi adapter itself. So 10.0.17.1 that I'm using for this particular setup. Then I'm going to do another DHCP option equals 6, and it's going to, and a comma, it's going to go 10.0.17.1. And so what this is telling where the DHCP server is. Okay. So we did set up before on that on the actual interface, and that we set it up for 8.8.8.8. Did I say too many? I can't remember. And 1.1.1.1. But what this is advertising to any of the clients that's out there is like, hey, any DNS request, just send it to 10.0.17.1. So which is the Raspberry Pi Wi-Fi access point or Wi-Fi router. Once we're done that, Control X. We want to save the buffer. We're going to, well, you wouldn't be able to see that. So just give me a second here. And I'm going to say yes. I'm going to hit enter. Okay. So now what we have to do, we have to change our, we're going to clear this off first. We're going to change our directory. We're going to go etc, and then we're going to go systemctl or sysctl.conf. Oops. My mistake. We're not going to do that. We're going to go nano. Okay. And what we're going to do is we're going to enable packet forwarding for IPv4. So what we're going to do is we're going to come down and we're going to look for this line here. net.ipv4.ip_forward equals 1. So it's commented out. So all we need to do is uncomment it. So just delete the hashtag or the pound sign. Control X. We want to save the modified buffer. Yes. And we want to hit enter. Okay. So now what I need to issue is this sysctl-p. And so now we have the ability to forward everything now. So we're good for there. Now, the next thing we're going to do, I'm going to clear, and now we're going to work on our network address translation. What we're going to issue is we're going to say IP tables dash dash table nat dash capital A, and then all of this is in capitals, post routing, whoops, and then dash small lowercase o eth 0, then dash j capitals masquerade. Okay, so what we're essentially doing is we're setting up our network address translation, and then we are going to hit enter. Then the next thing we've got to do is issue a command, sh-c, just a single quote, IP tables, save, etc, IP tables, rules.v4, and then close that with a single quote. And then we're going to hit enter. Oh, I need to put that there. IP tables. Okay, we're all good. Okay, so now what we're going to do is we're now going to start up our hostapd and our DNS mask services, plus also as well enable them so that they can be automatically launched every time that the Raspberry Pi either powers up or it boots up. So what we're going to do is we're going to issue systemctl start hostapd. Great, that worked. Now we're going to do systemctl start DNS mask. Awesome. Now what we're going to do is we're going to enable them so that they can launch automatically in that when we do power up the Raspberry Pi or reboot it. So we're just going to do systemctl enable hostapd. And then we're going to do a systemctl enable DNS mask. Okay, awesome. So then what I'm going to do now is I'm going to shift screens over and we're going to connect up to this brand new Wi-Fi router. All right, so we've got our Raspberry Pi now configured to be a Wi-Fi router. Now what I've got on the screen here is a Net Ally AirCheck G2. I wanted to bring this up because it's really cool that I'm able to show some good information with regards to our configurations and also as well making sure that everything is configured properly. So the AirCheck G2 had discovered Greybeard ham. It's showing that there is one access point, which is this particular BSSID, which is no problem. That's all good. So that means that it is beaking out Greybeard ham. So I'm going to jump over some of this for now, but I'm going to talk about security. We've got our WPA2 personal, which we did configure. Also as well, which bands that we're on, we configured it to be on 5 gigahertz and channel 36. So we're doing awesome so far. Now, one of the things I wanted to kind of show everybody is one of the limitations, as I mentioned earlier in this video, of using a Raspberry Pi as a Wi-Fi router or an access point is that if you use the internal chipset on the Raspberry Pi, it doesn't really have that great of an antenna, and the performance of it is kind of not as good as what you would get in a commercially available access point, or even go to your favorite box store and buy a Wi-Fi router. But for my application, or maybe even yours as well too, going to be close proximity. It's not going to be a big deal. So we could turn around and look and say, hey, you know what? I'm minus 63 dBms, and my Raspberry Pi right now is in the next room from my office, and it's connected up to an Ethernet connection. 30 dB signal noise ratio, that's okay. You know, the bigger the number for your signal noise ratio, the better off you are. All right, so let's go and do a connection test to see if this works. So we just clicked on connect and we see that it's established a connection. So that means it's authenticated and associated. It has obtained an IP address from the DHCP server that we've configured. Also, as well, confirm the gateway and also the DNS server that we configured. Remember, we only configure one DNS server in here. The nice thing about the air check, what it will do is once it has established a connection, got an IP address, it will go out and ping a target. And so by default, inside the air check, they will ping the google.com address. And so the green means, hey, we're able to ping it. So now we confirmed that we do have Wi-Fi connectivity, we got an IP address, and we also have internet connectivity. So the network address translation works on the Raspberry Pi. So I hope you enjoyed this video. I really enjoyed putting it together for everybody. I hope that you do see some value in this, and maybe in any of your projects and that, or configurations and that you want to do, let me know about them. Hey, I'm interested. So please leave a comment below on how would you use something like this, like a Raspberry Pi, to be an access point or a Wi-Fi router. Okay. And if you really like the video, make sure you click on the thumbs up button, and make sure you do also subscribe and hit the bell notification so that you know when there's going to be other Graybeard Wi-Fi videos out there. Okay. So once again, have a great day. I'm glad that you joined me today in learning how to take a Raspberry Pi and making it into a Wi-Fi router. All right. So have a great rest of the day. Take care, and we'll see you later. Peace.